Good evening everyone, welcome to online GDC platform. So on our GDC app, today we have conducted GDC weekly test on pharmaceutical analysis subject, and in this subject also majorly the focus topic in today's weekly test of analysis is introduction of the pharmaceutical analysis and introduction of the spectroscopy. Okay, these two topics we have conducted weekly test. So in order to attempt the test, already you know that the step 1 is you need to download the GDC classes app. Afterwards go to the batches, okay, then click on the plus sign. Afterwards the step 3, type the batch code GDC quiz. So already we have started and we have ended the session also, but this review session has been delayed by just 1 hour. Actually it was planned at 7 p.m. So some due to some unconditional sequences, 1 hour delay has been happened. Sorry for that. Let us continue our review of this weekly test questions. Okay. So in our GDC app, you know that we are conducting so many types of the tests like weekly tests as well as daily practice paper tests. Okay, whenever the subject topic is over, we are going to conduct number of tests, and we are giving the ranks to the students also, whoever has done very good in those exams. So let us see who has scored more marks in today's weekly test. Okay, so first question, if you observe in this GDC analysis weekly test, if the energy of the electromagnetic radiation, so spectroscopy related question, introduction of the spectroscopy, all the basic questions you are going to see. Basic means definitely you are going to observe what is electromagnetic radiation, what are the wavelengths and the wave numbers, energies, how these are going to be related, right? So all these you are going to see it. So if the energy of this electromagnetic radiation increases, what happens to its frequency and the wavelength? The question, the first question is energy of the electromagnetic radiation. We know that E equal to h nu. So E, sometimes the change in the energy we are going to take it delta E. H is the Planck's constant and nu is the frequency. Okay. So for the electromagnetic radiation, whenever we are going to see any energy change, we are going to observe the relation in between the energy as well as frequency. So here the energy of the electromagnetic radiation, it has been increased, then what happens to its frequency and the wavelength? So this energy is directly proportional to the frequency. So automatically if energy increases, frequency also increases. But if you are talking about the frequency, okay, so frequency and wavelength, here they have asked the wavelength also, right? So frequency and wavelength, these are inversely related. So if the energy increases, frequency also increases, but wavelength decreases, right? So in the given options, frequency increases, wavelength increases. No, it is not the right one. Frequency decreases. No, not at all. Frequency decreases. No. So frequency increases and wavelength decreases. So obviously option D, it is going to be the right answer. Okay. Next, the wave particle duality of the electromagnetic radiation. Okay, we know that electromagnetic radiation is possessing the both electrical property as well as magnetic property. It has certain wavelength and energy and frequency, right? So wave particle duality, that means the characteristics it is going to possess of electromagnetic radiation. What it means actually? Let us see the options. Behaves only as a wave, behaves only as a particle, behaves as either a wave or a particle but never both, appears to behave like wave at times and like particles at other times. Okay. So if you see, the first 3 options are not correct, only half of the part is correct. Only the option D, the electromagnetic radiation, it is having both wave and particle duality properties. So it appears to behave like a wave at all the times and like particles at other times. Okay. So that is the right answer. Next question, when a molecule absorbs the IR radiation, what type of transition is primarily induced? The question is, whenever that means when any molecule, because all these absorption spectroscopy, UV, IR, NMR, visible, okay. So, all these fluorescents are going to be at the molecular level, and when a molecule absorbs the IR radiation, that means infrared radiation, what type of transition is primarily induced? We know that for each radiation certain wavelength has been defined, and at the particular wavelength it is possessing some energy and frequency. Whenever IR radiation is being used, so what is the type of transitions? For UV, if you are observing, the electronic transitions are required, or electronic transitions are majorly affected, as well as IR radiation, if you are talking about, means vibrational transitions are going to be occurring. So, let us see the options. Electronic transitions, movement of bonding electrons, no. Vibrational transitions, vibrating with the greater amplitude. A rotational transition, rotating faster. Nuclear spin transition. Actually, so if you observe these options, how they have given, this is related to UV, rotational means microwave, okay, and nuclear spin means this is related to the NMR. So, only the vibrational transitions whenever we are talking, that is related to the IR. So, very simple to answer, option B, it is a suitable one here, okay. Next, fourth one, if you see, which of the following correctly orders molecular transitions from lowest energy to the highest energy, okay. That means whatever the lowest to the highest energy, if you are observing, so anyone has answered this question? Let me see. Live chat. Okay. So, what is the answer for this question? Let me check who have given the right answer first. Okay. Yeah. So many are giving the right answer. So what they have asked here, which of the following correctly orders the molecular transitions from lowest energy to the highest energy? Lowest energy to the highest energy, okay. So let me check who has given the right answer. Okay. First option they have given electronic less than vibrational less than rotational, and second one vibrational is less than rotational is less than electronic, and rotational less than vibrational less than electronic. Next, rotational less than electronic less than vibrational. They have just jumbled it, but finally electronic, vibrational, rotational, these three only they have focused. So molecular transitions from the lowest energy, highest wavelength, right? We know that very well. So let us see first of all explanation for this, that means how the energy levels are being different, okay. That means whenever we are going to see that energy levels for a molecule, any relative transitions are there, okay. The energy levels whatever the UV, IR, microwave, these three are focused here, okay. So here if you see the rotational, it is going to be having the less, afterwards vibrational, afterwards electronic. From the lowest to the highest they have asked. Highest wavelength, if you are talking about these three levels, UV is having the highest wavelength. So, almost all, if you are going to see the 200, lowest wavelength, okay. So, energy, it is going to be a reversal of the wavelength, okay. So, UV, if you are talking electronic transitions, 200 to 400 nanometer and 800 nanometers. So, afterwards vibrational means IR. So, 2.5 to 25 microns, then 25 to 1000 microns, if you are going to see, those are comes under the rotational, okay. So, wavelength, it is going to be increased here. So, automatically the energies are going to be in the reversal. Here wavelength is high means energy is less, right. So, rotational transitions, vibrational transitions and electronic transitions. So, these three whenever we are talking, wavelength increases, energy decreases. So, in that way you can remember very easily, okay. So, for that purpose you can answer now. The rotational are having the lowest energy, then vibrational, then electronic, okay. Highest energy, it is going to be possessed by the UV radiation, okay, then IR radiation, then microwave. In this scenario, not about entire electromagnetic radiation, okay. So, for that purpose you need to know gamma rays, X-rays and all these things. Again, just here in this question they have focused only 3, okay. Okay, we will move to the next question. Why are molecular absorption spectra in the UV visible region typically broadband rather than sharp discrete lines, okay. Sharp discrete lines means whenever we are taking the mass spectra and NMR spectra are there, okay. So, in those cases we are going to observe some of the sharp lines, but in case of the UV we are going to see the bell shaped curves, or these are going to be called as the broadband curves, typically broadband curves, okay. So, why it is going to happen in this UV absorption spectra? Let us see the options. Because all molecules of the substances are in the ground state, because the energy of the UV light is too high, because electronic states have many associated rotational and vibrational sublevels. This is also going to be the perfect answer. Because atoms and monoatomic ions cannot rotate or vibrate. No, that is not the case. Actually, the suitable answer in this question, if you observe, the electronic states, whatever the electronic transitions, it is going to be possessed by the molecular level, okay. So, they are also going to be associated with the vibrational as well as rotational transitions are also, energy levels are going to be involved, but UV majorly it is going to focus on the electronic transitions only, but as such it is going to possess all the energies. So, energy it is going to be combination of all these electronic, rotational and vibrational, okay. So, then only you are going to see that different changes are going to be observed by passing the radiation at the different wavelengths, right. Next question, if you observe, according to Beer's law, the relationship between the absorbance and concentration, okay. So, how many have answered this question very well? Right answer, how many? Okay, yeah, okay, yeah, very good. So many have answered very good. Let me check. What is the correct answer? According to Beer's law, the relationship between the absorbance and the concentration. We know that what is Beer's law? A equal to epsilon into C into T, or we can also write A equal to epsilon into B into C, right. So, this is the absorbance and this is the molar absorptivity value or molar extinction coefficient. C is the concentration. D, B or T both are going to be representing the path length. Okay. So here if you observe, according to Beer's law, the relationship between the absorbance and concentration. This is actually the combined equation for the Beer's-Lambert's law. Path length and concentration both are clubbed in the one equation. But according to only Beer's law, if you observe, absorbance is directly proportional to the concentration. Okay. So it is going to be either exponential, logarithmic, linear or inverse. So if absorbance increases, the concentration, that means both are going to be linear to certain level only. Okay, but not at high concentrations. So if you observe the other three options, these are not correct. So that's why the linear it is going to be the suitable answer. Okay, next equation wise or some of the definitions also come into this question. What is the mathematical definition of transmittance? What is absorbance? What is transmittance? For that purpose, you need to know what is called incident light I0. Always we are going to represent the incident light as I0 and transmitted light as IT. Sometimes we are going to represent this transmitted light as simple I also. But incident light definitely we are going to represent as I0. Okay. Here they have asked the definition of transmittance. Okay. Transmitted light. So options T equal to I0 by I, that means this is the transmitted light, and T equal to minus log of I by I0, T equal to log of I0 by I, and T equal to I by I0, that means the transmitted light divided by incident light. The simple way, only transmittance if you are talking means the transmitted light divided by incident light. It is going to give you the percentage of transmission. That is called as transmittance in simple terms. Okay. So these logarithmic values, these are going to be come into the picture whenever we are correlating the absorbance and transmittance. But as such, absorbance is this is a I0 by IT, whereas transmittance reversal I0 IT by I0. Okay. So that is the correct answer. Next, in the Beer's law equation A equal to epsilon BC, what does the symbol epsilon represent? Just now we have discussed Beer's-Lambert's law, A equal to epsilon into BC. Epsilon represents the molar absorptivity or molar extinction coefficient. B is the path length and C is the concentration. Okay. So let us see the options. Absorptivity, molar absorptivity, path length, concentration. Definitely the answer is molar absorptivity, not the simple absorptivity. Okay. So path length is B, concentration is C. Very simple question. Next, which of the following is a common reason for the Beer's law to show deviations at high concentrations? Which of the following is a common reason for Beer's law to show deviations at high concentrations? So Beer's law, already we have discussed that A is directly proportional to the concentration, but to the some extent only. At high concentrations, it is going to deviate. What is the reason behind it? This one already we have discussed in the live class also. Let us see the options. Analyte molecules began to interact with each other. Definitely. The path length of the cuvette changes. No. The molar absorptivity becomes 0. No, not at all. The instrument source becomes too bright. Not a relevant answer. This one D is only the option A. If you see, analyte molecules began to interact with each other. That means whenever the concentration becomes high, what happens? The space between the atoms, it is going to be getting very closer. So intermolecular forces are going to be there. Thereby the transmission of the light, it is not going to take place. Automatically it is not following the linear path. At high concentrations, this is the problem. Okay. So option A, it is the right answer. Next, a continuous source of radiation is 1. Okay. So this question is related to the source of the radiations in the spectroscopy. In the sources, we should know the whatever the source of light or whatever the electromagnetic radiation it is generating, it should give a pulse free radiation as well as some discrete lines or a continuous spectrum, how it is giving. Okay. So, all these are going to be some of the properties of the source. Now, a continuous source of radiation is one which is exhibiting a continuous source. That means it emits only few discrete wavelengths, continuous. You are going to see the spectrum, whatever the lines, we are going to sometimes discrete lines are going to be observed and sometimes a continuous spectra it is going to be observed. It emits the radiation over a wide range of wavelengths S. No disturbance, okay, no discrete lines we are going to observe. It is a continuous range, continuous wide range of wavelengths, emits only coherent light like a laser. It is used in Fourier transform spectrometers. No. Fourier transform means again we are going to see a beam splitters in order to have the movable mirrors and all these things. Only the option B emits the radiation over a wide range of wavelengths, so that we are going to see the each and every wavelength we can get the value of the absorbance. So, that is called as the continuous source. No discrete lines it is going to give. Okay. Next question, if you observe, yeah, so many have given the answer, right answers. Everybody is giving. Okay. So, let me check who is giving the right answer. For this 10th question, if you observe, which of the following is an example of a line source used in the spectroscopy? Okay, just now we have discussed the continuous source of radiation. Now, the line source used in the spectroscopy. Tungsten filament lamp, deuterium lamp, heated solid ceramic, hollow cathode lamp. So, in case of the hollow cathode lamp, where we are going to use this atomic absorption spectroscopy, where we are going to analyze the elemental analysis. Okay, only specific element it has to be absorbed. In that case, only the line source, only discrete lines are going to be observed. Among these three, if you observe tungsten, deuterium and heated solid ceramic, we don't observe the line source. Okay, only in case of the hollow cathode lamp we are getting the discrete lines. So, that is why option D it is going to be the right answer. Okay. So, other options tungsten, deuterium and ceramics are examples for the continuous sources of the radiations. Okay. Next question, what is the main advantage of a double beam optical system over a single beam system? Okay. So, mostly till now we have seen the questions related to the spectroscopy only. So, each and every part, the basics of the EMR. Now, we are seeing the optical systems over a single beam. So, why single beams spectrophotometer are replaced? That means now we are going to use so many double beam spectrophotometer. Okay, because we are going to get the drift and everything are minimized. Let us see main advantage of a double beam optical system over a single beam system in this question. It uses two detectors, making it faster. No, not at all. It does not require a radiation source. This is also wrong answer. It can correct for the drift in the source intensity. Yes. So, option C it is going to be the right answer. It has a higher resolution. No. So, resolution wise it is not going to affect. Only the double beam and single beam, they are going to be differ from the source of the radiation. The both reference as well as sample are going to get the whatever the source it is there, it is going to be taken by the reference and sample. Okay. So, that is the radiation. In between that you are going to see the monochromators, all the entrance slit, exit slit. Okay. So, dispersing devices, different types of the gratings we are going to use, but from the source we are going to see the two sources of the radiation. Okay. Only source is only one, but it is being split into the two beams. That's why it is called as double beam. Okay. So, in this case the slow variation in the signal. So, whatever the drift you are going to observe in case of the radiation, it is going to be observed in both the cases as same, so that we are going to see the less noise. Okay. So, the spectrum whatever we are going to observe may be a very sharp line you are going to see, but it is not like that. Sometimes you are going to see the like, okay, noise it is going to be very high. So, in that way we are not going to observe in case of the double beam spectrophotometer. So, drift it is going to be minimized, and some other advantages like double beam spectrophotometers, we can analyze both reference and sample at a time. Okay. But single beam means you need to put first reference, then take it out and then put the sample. That is not going to happen in this case. Okay. Next, a spectroscopic instrument that uses a filter to select the wavelength, it is called filters. Filters, gratings are going to be used in order to convert the polychromatic light to the monochromatic light, that is called as actually monochromator. So, those instruments are going to be called it as spectrophotometers, where we are going to get the entire spectra over the entire wavelength range. But in case of the filters, if we are going to use, only it is going to give you specific wavelength only. Okay. So, in that case we are not going to call that one as the spectrophotometer, it is just a photometer. So, option C it is going to be the right answer. Spectrometer, spectrograph, interferometer, these are not the suitable answers. Okay. So, photometers means simple filters we are going to use. So, in those cases we are going to use the filters. Okay. So, in order to have the absorbance at particular wavelength. Okay. Those filters are also having plus or minus 5 nanometer or plus or minus 50 nanometer bandwidth. It is going to be very high in case of the filters. So, whenever filters are going to be used, we cannot get the spectra for the compound, only the absorbance at particular wavelength only we can get it. Okay. But in case of the spectrophotometers, interferometers, we are going to get the entire spectra. That means from 200 to 400 nanometers entire spectra we are going to get it. So, in those cases we require the monochromators, but if we are going to use the filters means it is just a simple photometer. Okay. So, option C it is the right answer here. Next, what is the primary function of the exit slit in the monochromator? Monochromator actually it contains both exit slit as well as entrance slit, right? Whenever the light radiation it is passing from the source, first it enters the entrance slit. Okay. So, then entrance slit you are going to observe the lenses. This is the source if you are assuming. Okay. So, radiation whatever it is, if it is a double beam you are going to observe the, let us say if the prisms are used or gratings are used, this is going to be the dispersive element. Then again exit slit. Okay. So, this is going to the exit slit. This radiation we are going to observe, and this sample holder, okay, through the sample it is going to be absorbed. So, it is generally happening in case of the absorption spectrophotometer. Here what is the question? Primary function of this exit slit. Monochromator means it is a combination of both entrance slit, prism, dispersive element and exit slit. If these three are going to be combinedly called it as monochromator. Let us see the function of the exit slit. What is the purpose? To collimate the light from the source. Actually, some collimators are also going to be used, but that is not the purpose of exit slit. To permit only very narrow band of the dispersed light to pass to the detector. Yes. Option B it is going to be the right answer. To reflect the light into the dispersion element. To serve as the sample holder. No. Very irrelevant. Okay. So, reflection nowhere it is going to be happening. Only option B it is going to be the right answer. To permit only a narrow band of the dispersed light to reach to the detector. That is the purpose of the exit slit. Okay. Only the selected wavelength only it is going to be passing through that. Right. So, let me check Who have answered the question very correctly? Okay, very good. So many have given the right answer. Okay, fine. So let us move to the next question now. So this is how the polychromatic light, it is going to be converted to the monochromatic light. So this exit slit, whatever we are going to use, a narrow bandwidth only, even though it contains so many colors, only one color only, very a narrow bandwidth light it is going to be dispersed, right? Okay, next question. The process of an atom or molecule emitting the light after absorbing the incident light is broadly termed. The process of, here they have given the terms in the and multiple options, whereas the definition they have given in the question. Okay, so let me see. The process of an atom or molecule emitting the light, this is not absorption, emission of the light after absorbing the incident light is broadly termed. Okay, that means in case of the fluorescence spectroscopy we have studied this term, whatever the fluorescence or phosphorescence, but emission of the light, it is going to take place whenever after the absorption of the light has been done, right? So in case of the UV light as well as visible light, we are observing this type of the emission of the light, it is going to take place. Once the emission of the radiation has been observed immediately, that is going to be called as fluorescence. After some time it is going to be called as phosphorescence, delayed, this is delayed fluorescence, but both are going to be comes under luminescence, the emission of the light after absorption of the light, that means from the ground state the absorption it is going to take place, then excited to the excited state. From the excited state again relaxation it is going to take place, then emission of the light it is going to be exhibited by some of the molecules, not by the all the molecules. Okay, so that is called as luminescence. Absorption means initially the ground state atoms or molecules are going to do scattering of the radiation, it is going to be done by the particles present in the solution, and transmission it is whatever the after absorption, whatever the remaining unabsorbed light it is there, which is transmitting through the sample, that is called as transmission. Okay, so the right answer here is option C, luminescence, it is a correct definition for this. Next, two statements are given. Okay, this is a statement question, so read it carefully. So I should know who have given the right answer for this statement related questions. Okay, so let me check who has given the right answer. Yeah, someone has answered. Let me see whether they have answered correct or not. So this statement, an assertion and reason, mark the correct answer from the options below. What is assertion here? The energy states of the atoms, ions and molecules are quantized. Definitely these are going to be quantized. How much energy it is going to be there? Definitely at the atomic level, ionic level and molecule level. Everything, every state, the energy it is going to be quantized. So what is the reason? Matter can absorb or emit only the specific frequencies or wavelengths that correspond to the exact difference in the energy. Yes, that is called as delta E between the two allowed states. So reason is right. Okay, let us see. Both A and R are true, and R is the correct explanation of A. Definitely A is the correct one. Both A and R are true, but R is not the correct explanation. No, R is the correct explanation. A is true, R is false, A is false, R is true. These two are not suitable answers. Option A, it is going to be the right answer. Okay, both A and A are, but that means assertion and reason both are true, and R is the correct explanation of the A. Okay, let us move to the next question. Okay, this is also related to the statement wise question only. Assertion, what is that? In a vacuum, the speed of light is constant. Yeah, we know that. And does not depend on the wavelength. Definitely. Reason, when light passes from a vacuum into a material, its wavelength must decrease because its frequency changes. No, not at all. So R is not the correct explanation of the A. Okay. So whenever any medium it is there, then the wavelength it is going to be changed. But when it passes through the vacuum, it is constant. Okay, and it is not depend on the wavelength. So let us see the options. A and R are true. R is the correct explanation. No, this is wrong. A is true, but R is false. A is false, but R is true. So okay. So by seeing this, we can say that A is true, but R is false. Okay. Why? Because whenever the light enters the any medium, okay, then like solution or gaseous phase, anything, whenever light passes through any matter or any medium, then the frequency it is not going to change, okay, but only the wavelength it is going to change. But in a vacuum, it is not going to depend on the wavelength, okay, it is constant. That is a light characteristic. Okay, next, again the statement related question. Here let us see the assertion. A linear relationship exists between the absorbance and the concentration. According to Beer's law, A is directly proportional to the concentration. Okay, so that we know very well. Next, what is the reason? The intensity of the transmitted light decreases exponentially with increasing the path length. That means here they are talking about the Beer's law. Okay, but in this, the intensity of the transmitted light decreases exponentially with increasing the path length. And reason they are supporting whether the statement or not. So whenever we are giving the light energy, then what happens? Something it is going to be absorbed, whatever the remaining it is, that is transmitted. Okay, so that intensity of the transmitted light, it is going to be decreases. Okay, whatever the total energy we are going to give, the intensity it is going to be decreased exponentially with increasing the path length of the radiation. So path length means this, according to Beer-Lambert's law, if you observe, A equal to epsilon into B into C. Okay, so this B is related to the path length. So with increasing the path length, the transmitted light, whatever it is there, okay, so it is going to be decreased. So automatically, that means that is also going to be logarithmically. That means A and transmission, if you are going to observe the relation between the absorbance and the percentage transmission, that is A equal to 2 minus log of percentage T. Okay, so absorbance as well as transmittance are going to be exponentially related, right? So that's why A and R are true and R is the correct explanation of the A. So option A, it is going to be the right answer. I think no one has confused this one, right? So many have given the correct answer. Why it is yeah, someone is asking why it is supporting. Actually, just now I have explained. Okay, this is whenever transmission it is going to takes place. The transmission exponentially if you are taking means 10 to the power of minus ABC. That is also going to be one of the formula related to that. Okay, and this transmission and path length, how these are going to be related. Okay, so that is also going to be explained by the Lambert's law also, and he also given some information that the intensity of the light, how it is going to be decreasing that, right? So that's why the relation between this absorbance and transmittance, if you are going to see, definitely you can say that both are true. Okay, next, which of the following statements about the radiation source is correct? About the radiation source they are telling. An ideal source should have intensity that fluctuates rapidly over short time intervals. Ideal source means it should not fluctuate. So obviously the statement ideal source should have an intensity that fluctuates. Okay. So obviously this is the false statement. Okay. Next, a tungsten filament lamp is a common continuous source for the visible region. Okay. Common continuous source. Next, a deuterium lamp is a common continuous source for the IR region. No, this is for the UV region. Okay. So this is also wrong. This is also wrong. Lasers are considered high intensity coherent line sources. Okay. So this we can consider it. So let us see 2 and 4. Which of the sources are correct? Okay. Correct statements means 2 and 4. Only 2 and 4 are correct. Remaining, that means first one is wrong and third one is also wrong statements. Okay. Got it? Okay. Yeah. So no confusion in that this question. Let me check the another question. 20th question we have coming to that. Which of the following statements regarding optical systems are false? Okay, here they are asking the false statement. What is a false statement? In a double beam system, the radiation from the source is split into reference beam and sample beam. Okay. So in double beam system, it is going to be split into 2 beams. In a double beam system, measures the absolute intensity of the sample. Absolute intensity. Definitely, because again as the reference it is taking means, so this is also going to be the right. So this is true, this is true. Single beam optics are not subject to errors caused by drift. No. Single beams optics are subjected to errors because of the drift. That's why double beam instruments we are going to use. Okay. So this is the false statement. Option 3, it is false. Next, a chopper or rotating disc can be used as a beam splitter. Okay. So in case of the hollow cathode lamp, that means atomic absorption spectroscopy, we are going to use the choppers in order to give the radiation as a beam splitter. Okay. So here false statement, they are telling that a double beam measures the absolute intensity of the sample beam. This is also actually absolute intensity, it is a right. Okay. So only here if you observe the false statement, which of the following is false? The 3, only 3 it is going to be the false statement. Okay. So why only 2 is also, that means it is not giving the absolute intensity. A double beam system measures the absolute intensity of the sample beam. Actually again as the reference itself it is giving the absolute intensity. The another term if they are observing, okay, so only the third statement is wrong here, remaining 3 are right. Okay. So in this options they have not given that, so everyone will get the mark definitely. Next, okay, again the statement related question. Consider the following statement about the interaction of radiation and the matter. Choose the correct. Interaction of the radiation with that of the matter. Absorption of radiation increases the energy of the absorbing species. Okay. So choose the correct answer. Here they are asking the correct. What is the true statements? Absorption increases the energy of the absorbing species. So whenever we will give energy, automatically the energy it is going to be taken up. So it is going to be excited to the excited state. So this statement is true. Next, emission of the radiation increases the energy of the emitting source. Emission. So emission, when it is going to take place actually? After absorption, again relaxation. That means energy is lost. Then only relaxation it is going to take place in case of the fluorescence. So definitely emission of the radiation, it is going to decrease the energy, because while coming back to the ground state only it is emitting the energy. That energy we are taking as emission. Okay. So this statement is false. Next, The set of frequencies and intensities at which a species absorbs is called spectrum. So, this is called as the spectrum, the set of the frequencies and intensities at which a species absorbs the radiation. Then only we are going to get the spectrum, whether it is an IR spectrum or UV spectrum. So, this statement is also right. So, that is why option 1 and 3 are right, whereas 2 is the wrong statement. Okay. Next, which of the following statement about the instrument nomenclature? Wow, instrument nomenclature they are asking. So, mostly we are seeing the questions related to the basics of the spectroscopy only, right? So, let me check what are the statements related to the instrument nomenclature. Spectrometry is a quantitative measurement of the radiation intensity. Measurement of the radiation intensity. Definitely, we are going to take the measurement quantitatively, we can estimate. That is right answer. So, option first one, it is a right statement. Next, photometer uses a grating to select wave. No, photometer means we are going to use the filters. Okay. So, gratings if you are going to use means that is called as spectrophotometer. Okay. So, that is not called as photometer. So, this statement is false. Next, a spectrograph uses a solid state imaging detector instead of tiny exit slit. Only exit slit, it is not sufficient, right? In order to capture the spectra, definitely we are going to use the solid state imaging detector. That is why we are going to use photovoltaic cells, photo tubes. Definitely cathode should be there in order to get the light radiation incident on the cathode. Okay, all the multiplication of the electrons, it is going to take place. And in case of the UV as well as IR also, we require the solid state imaging detectors, bolometers, pyroelectric detectors, all these are. So, this is also right. So, 1 and 3 are the right statements, whereas 2 is the wrong statement. Okay. So, option B, it is going to be the right answer. Next, match the type of the molecular transition with the primary region of the electromagnetic spectrum that causes it. Very, very simple. If you know exact the one combination also, you can easily answer the matching type of the questions. Okay. So, what they have, energies they have given and spectra, that means whatever the related rays, radiation, okay, molecular transitions, and these are going to be primary region of the electromagnetic spectrum they are asking. Rotational, vibrational, electronic and core electron. So, if you observe, already we know that vibration is related to infrared and electronic related to UV visible. Okay. So, if you know these two answers, you can correctly match this. So, 1D and vibrational 2D. Okay. So, where the 2D it is there? Option A has 2D as well as option D also has the 2D. So, let us check electronic 3A, right. So, where the 3A, oh, here also 3A, here also 3A, but here this is not the right answer. So, option A, it is going to be the right one. So, if you observe the rotational energies means these are going to associate with the microwave. Okay, that is why 1C it is going to be the one. And electrons, whenever the core electrons are going to be involved means in case of the X-ray and electron spin resonance spectroscopy ESR, there also electrons are going to be involved. Okay, so what is the right option here now? The option A, it is the suitable one. Okay, so easily you can answer this matching. Next, match the spectroscopic component with its primary function. Spectroscopic component with its primary function they are asking. Let me see what are the matchings here. Column A, component, here function, continuous source, monochromator, detector, double beam optics. Here what they have given, convert the radiation into the electrical signal. So, what actually it is doing? Radiation energy into the electrical signal, it is going to be done by the detector. Okay. So, 3A here So options, here also 3A it is there, here also 3A it is there. Okay. Next, monochromator. Monochromator, what it actually is doing? It is here if you observe the options, disperse the light and select the narrow band of the wavelengths. This is the right answer for the monochromator. So 2D. So where is the 2D? Only here. So obviously option B it is going to be the right answer. Let us see another option, another statements also. Continuous source and double beam optics. Continuous source means what it actually doing? It emits the radiation over a wide range of the wavelengths. Throughout the wavelength range, we can get the continuous source of the radiation, so that the entire spectrum can be obtained. And double beam optics, what they are, why we are going to use a double beam means they are going to correct the drift. Okay, so drifts are going to be minimized in case of the double beam instruments, right? So this is also an easy matching in this point of view. Next, I think everyone has given the right option for this. Okay, yeah, okay. Next question, match the radiation source with its description or primary use. Match the radiation source. Source they have given and with its primary use they have given. Okay. And in this, who has given the right answer? Let me check. Okay. So in this, if you see, the deuterium lamp, tungsten lamp, hollow cathode lamp, heated solid ceramic. So whenever we are going to use the deuterium lamp means we know that is related to the UV radiation, right? So very basic question, you can say that. So deuterium lamp, continuous source for the UV region. So 1C. So where you are finding 1C? Because time is very important also. Whenever in the exams, if you in matchings mostly, if you know one answer which has been observed in one option, then you can blindly go for it. Okay, exact, if you know the confirm answer, then only you can choose that. And tungsten lamp means it is going to be used for the visible region. So tungsten, this is for the 2D. So 1C and 2D. So if you observe in these four options, 1C here also there, but 2D only option A it is there. Okay, so that's why option A it is the right answer. Hollow cathode lamp, we are going to use it for the atomic absorption. So 3A here also there. Heated solid ceramic, 4 it is going to be used in case of the IR region. Okay, so option A it is going to be the right matching. Very easy also. Next again one more matching. Match the wavelength selection. Match the wavelength selection device with its operating principle. Absorption filter, interference filter, prisms and diffraction gratings. Okay, so let us see. Disperse the light by constructive interference from closely spaced grooves. Disperse the light based on the change in the refractive index with the wavelength, and transmits the selected wavelength based on the constructive interference in the multiple layers, whereas selectively absorbs the unwanted wavelengths of the light, that means colored glass. In this, if you observe, the colored glass filters are going to be used in case of the absorption filters. Okay, selectively absorbs the unwanted wavelength of the light, only allows the required radiation. Okay, so those are going to be called as absorption filters. So 1 it is going to be related to the D, option D. So here if you observe 1D, here also 1D it is observed. So next option, interference filters. Interference filters, actually these are also related to the wavelengths only. So these are going to transmit the selected wavelengths, and constructive interference it is going to takes place. Okay, So that is the purpose of interference filters. So 2C. So where 2C is observed? Only here. So option A could be the right answer. Third one, prism. So what actually prism is doing? This is a dispersing element. So this here also dispersing we are going to see. But in case of the prism, if you observe, based on the refractive index, it is going to be refractive index, it is working, whereas gratings are going to be interference. That is also a constructive interference, it is going to take place, and grooves are present on the gratings, right? So option 4A, if you take this is the correct matching. So option A, it is the right answer. Okay, next 27th. Consider the following. Consider the following. Who has given the right answer? Let me check. Okay. Consider the following statements regarding the fundamental concepts of the spectroscopy. Here the statements they have given. So let us see what are the statements here. Spectroscopy is the measurement and interpretation of the absorbed or emitted when molecules, atoms or ions move between the energy states. Definitely it is going to be the right answer. That means whenever this spectroscopy means the particulate matter, whenever it interacts with the electromagnetic radiation, it may happen at molecular level, atomic level, ionic level also we are going to see, and what are the energy differences. So option first one, it is going to be the right one. Next, electromagnetic radiation is composed of discrete particles known as photons. Definitely EMR, it is going to possess the photons. So this statement, it is also right. 1 and 2 are right. Next, EMR possess only wave characteristic, which is why it can travel in a vacuum. No, EMR also possesses the particle characteristics also. It has both electric and magnetic properties, right? So wave particle dual quality, it is going to be exhibited by the EMR. So 3, it is not going to be the right statement. Next, the energy of the molecule at its ground state is the sum of its rotational, vibrational and electronic energies. Definitely in the ground state all energies are present. Okay. So when we give the selective wavelength of the radiation, so each wavelength, it is going to have impact on the selective transitions. So definitely this fourth statement, it is also right. Next, frequency is defined as the distance between two successive maxima or minima. No, this is not frequency, this is the wavelength. So wavelength, it is going to be taken as two successive maxima and minima. This is going to be considered as the lambda max, and if you are going to observe negative peaks, lambda minima. Whatever it is, wavelength, that is called as, not the frequency. So 1, 2 and 4 are correct statements. So that's why option A, it is going to be the right answer. Next, evaluate the following statements about the classification of the spectroscopy. Okay, so for reading the statements itself, you may take so much of time, right? For let me check who has given the right answer for this. Evaluate the following statements about the classification of the spectroscopy. Classifications, we know that different absorption spectroscopy, emission spectroscopy, right? So all these are there. Let me check. Atomic spectroscopy, such as flame photometry, studies energy changes at the atomic level. So definitely atomic level means this is the right answer. Molecular spectroscopy, such as UV and colorimetry, energy changes at the molecular level. So if this is right, this is also right. So 1 and 2 are right. What they have asked, evaluate the following statement about the class. So which are the correct? They are asking on the correct statements. This is also right. Absorption spectroscopy studies the absorption of radiation and includes the techniques like NMR and IR. Okay, this is also UV and fluorescence are also there, but this is going to study the absorption and includes the techniques Those two, these are also right statement. Emission spectroscopy studies the emission of the radiation and includes the techniques like flame photometry and fluorimetry. This is also right answer. Oh, what they have given all the right statements. Let me check. Last one. NMR and ESR spectroscopy are examples of electronic spectroscopy because they use the electromagnetic radiation. No, these are not the electronic spectroscopies. Okay, here NMR and ESR, this is nuclear magnetic resonance, and ESR electron spin resonance. Here we are going to use the electrons but not in the NMR. Okay, so in the NMR we are not bothered about the electrons. So option 5, it is not the correct one. Only 1, 2, 3, 4. So in this option, this one, option C, it is going to be the right answer. Next, analyze the following statements concerning molecular energy states. That means how the energy states are going to be present in the molecular level. First one, the ground state is the most stable state of the molecule and possesses the least energy. Ground state. Here what they are asking, the following statement concerning the molecular energy states. Okay, ground state is most stable only. If we give the energy, then it will get unstable and more energy. Most stable possesses the least energy. Yes, HOMO and LUMO. So if you remember these two, you can lowest unoccupied molecular orbital, highest occupied molecular orbital. Okay, the excited state is highly stable state that contains less energy than the ground state. No, the excited state have the high energy. So whenever we will get some energy, we will be very highly excited. Similarly, the molecule is also. So excited state is not highly stable, it is least stable, get more energy. So these two are wrong. So that's why this is wrong. Next, the process where a molecule in an excited state loses energy and returns to the ground state is called the relaxation. Yes. So this is called the relaxation. After the absorption, then it gets absorbed energy and go to the excited state. After losing the energy, it will come down. That is called a relaxation. Okay. So 1 and 3 are the right options. So option B, it is going to be the correct one here. Okay, 30th question. Consider the following statements about the instrumentation components used in colorimetry. Colorimetry, if you are going to see, that means whenever we are going to observe the visible light of the radiation. Okay, so visible radiations whenever we are observing. So let me check who has given the right answer. A key requirement for a light source is that it provides a continuous and stable radiation over the entire visible spectrum. So definitely it is a continuous spectrum. Okay, so this is going to be the right option. The most commonly used light source in colorimeter is a tungsten lamp. Definitely, particularly tungsten, it is going to give the visible radiation. So this is also right one. Monochromators are used to convert monochromatic light to okay, reverse they have given. Polychromatic light to monochromatic. That is the purpose of monochromator. So option 3, it is wrong. In reverse order they have given. Absorption filters work by absorbing unwanted radiation and transmitting the required wavelength. Okay, so if you see this, absorption filters means they will absorb the unwanted radiation and allow the required wavelength. So this is also the right one. Next, when selecting an absorption filter, the color of the filter should be complementary to the color of the solution being used. That means complementary colors should be there. Okay, in the live class also we have discussed about what are the complementary colors. Okay, so definitely this is also the right answer. So only third statement is wrong. Let me check. Okay, already it is highlighted here. 1, 2, 4 and 5 are correct. 3 is not there. So option B, it is the right answer. Next, calculate the frequency of the light with mathematical calculations now. Okay, so let us do some calculations related to this. Till now we have seen the basic questions related to spectroscopy and analysis. Calculate the frequency of the light with the wavelength 500 nanometers. 500 nanometers, they are asking the frequency. Okay, so how we can solve this? So frequency means we know that the formula. Let us see this slide. Nu equal to, we know the equation delta E equal to h nu. H is the Planck's constant. Okay, and this nu frequency, it is going to be c by lambda, speed of the light divided by wavelength of the radiation, or wave number, it is going to be inversal of the wavelength. All these basic formulas we should know first. Okay, and one more thing, here what they have asked, 500 nanometer wavelength they have given, and they have asked to convert into the frequency. What is the frequency of this? So this formula is sufficient. If you know the speed of the light, we know the speed of the light is 3 into 10 to the power of 8 meters per second. Okay, and here wavelength, what is the wavelength? 500 nanometer. So this nanometer, here 3 into 10 to the power of meters per second. So 500 nanometers they have given. Nano means 10 to the power of minus 9 meters. So that's why you need to add 10 to the power of minus 9 here. So both are going to be the same units. So 3 into 10 to the power of 8 divided by 500 into 10 to the power of minus 9. So if you solve this, so these two zeros are going to be cancelling here. 5 into 10 to the power of minus 7, right? So if minus 7, this factor, if it goes up, it will become as plus 7. So all these are the exponential basic fundamentals of the mathematics. So now 3 by 5 into 10 to the power of 15. 8 plus 7, 15. Okay. So 3 by 5 if you do, you are going to get the 0.6 into 10 to the power of 15. So this is the answer we got. But in the options what they have given? 6 into 10 to the power of 14 hertz. Okay, we got 0.6 into 10 to the power of 15. So if you take 110 and multiply with this, it will become as 6. 6 into 10 to the power of 14 hertz. This is the right option. Okay. Next, calculate the energy of a photon with the nu equal to 5 into 10 to the power of 14 hertz. Okay, they have given the frequency now and they have asked us to calculate the energy E equal to h nu, right? So for that purpose, you should know what is the h value, what is the Planck's constant. So according to c means speed of light, that is 3 into 10 to the power of 8 meters per second. Similarly, Planck's constant value, what is that? This is also you should remember, 6.626 into 10 to the power of minus 34. This is the constant value for the Planck's constant. Okay. So E equal to h nu, this is the formula. So if you know the Planck's constant exact value, then only you can calculate this one. Just simply the multiplication only. But until unless you don't know the Planck's constant, you cannot do this. 5 into 10 to the power of 14 hertz. 5 into 10 to the power of 14 into the Planck's constant value. You are going to get the value that is 33.13 into 10 to the power of minus 20, because this is minus 34 and this is plus 14. Okay, so you are going to get the minus 20, but in the options if you observe, they have given 3.31. Okay, that means we need to take the 110 from here, so it will reduce 1 minus from here, 10 to the power of minus 19, right? So option A, it is the right answer. Next, calculate the wave number of the radiation. Okay, wavelength they have given and just they have asked the wave number. So wave number, if you see, that is the inversal of the wavelength only. Simply you can take the inversal value, but what the value they have given? 2 into 10 to the power of minus 6. Wave number equal to 1 by wavelength, right? What is the wavelength they have given? 5 into 10 to the power of 5. No, sorry. Two into 10 to the power of minus 6. Okay, 1 by 2 into 10 to the power of minus 6. Okay, 1 by 2 means it comes around 5. Okay, half. So, in this, if you take this 1 by 2 into 10 to the power of minus 6. So, if you take this 10 to the power of minus 6 above, it will become 10 to the power of plus 6. So, 1 by 2 into 10 to the power of 6. Okay. So, 1 by 2 means 0.5. So, 10 to the power of 6. This is the answer we got. But here what they have given in the form of meters. But the answer is in the centimeter inverse. Because wave number we are going to observe in the centimeter inverse. So, if you convert this, that is 0.5 into 10 to the power of 6, okay, meters we need to convert into the centimeters. So, into 100 if you take 5 into 10 to the power of 5, that is one thing, and 1, 2, 3, 4, 5. 5 zeros, 10 to the power of 5 means 5 zeros, okay. But here in the options if you see, they have given in the centimeter inverse, okay. So, 2 zeros we need to cut. Meters into centimeter conversion means you need to divide by the 100, okay. So, these 2 zeros, these 2 zeros. So, 5000 centimeter inverse, that is going to be the right option, okay. Yeah, they have given 500, 50,000, 5 into 10 to the power of minus 3. So, in these two you may get confused, but this is the right option. Next, calculate. Oh, one more calculation. So many of you have vexed up, right, for these calculations. Calculate the absorbance using A equal to epsilon by C, that is 𝐵-Lambert's law, where epsilon equal to 2500 liters per mole per centimeter, B equal to 1 centimeter and C. Okay, very easy actually. Only they are asking to calculate the absorbance only. So, just multiplication. They have given epsilon value, B value and C value. But C value how they have given? In the form of molar. Okay. So, if you observe A equal to epsilon into BC, this epsilon molar absorptivity, it is also should be either molar or moles per liter. Okay. So, here you need not to convert any figures, directly if you multiply this one, okay. So, 1, 2, 3, 1, 2, 3. So, 2.5 into 2, definitely it will become 5. Very easy question this is. Next, the molar absorptivity of a compound is, okay, they have given the epsilon value and 1% transmittance, calculate the concentration. Path length they have given and epsilon value they have given, okay, and what they have asked, that is calculate the concentration. C they have asked. So, in this percentage of the transmittance means actually 1, that is percentage of transmittance if you are going to observe. Generally transmittance means IT by I naught, transmitted light divided by the incident light, right. So, in this percentage of transmittance they have given as a clue, that is 1. So, 1 by 100 if you take, that will become as 0.01, okay. But you should understand what is the logarithmic value of this also. Minus log absorbance if you want to convert means logarithm of 0.01 minus negative logarithm, it will become as 2, okay. And you are going to ask the calculate the concentration here. A equal to ABC, we know that is the formula, that is epsilon into BC. So, in this we know that this is 2 and epsilon they have given 2500 and path length is 1 and we need to know the C. So, how we are going to get it? C equal to 2 by 2500, okay. So, simple value, sum of the negative logarithm of And in case of this percentage of tree also, negative logarithm of log 1, okay. So actually log 100, if you take the relation between the absorbance and the transmittance, A equal to 2 minus log of T. So this is also going to be taken, and whenever it is only 1%, okay, that is also going to become as a indefinite value 0.01, like that you are going to observe. So that's why absorbance will become as 2, and here percentage of transmittance and path length, it is going to be 1. So definitely you can calculate only based on the molar absorptivity value. So that's why 2 by 2500, it is going to give you the 0.0008, okay. So if you solve this, you will get it, the value like this. Next, path length is increased from 1 to 5 centimeters for the same concentration and wavelength. How does the absorbance change? Very easy question here, because we know that path length and concentration are going to be directly related to the absorbance by seeing this equation. So absorbance is directly proportional to the concentration, absorbance is directly proportional to the path length. So if you increase the path length 1 to 5 centimeters, absorbance will also get increased 5 times. So option A, it is going to be the right answer. Next, the extension coefficient, the molar absorptivity value, depends on what? Concentration only, path length only, molecular properties and the wavelength, temperature only. So definitely it is not going to depend on concentration, path length and temperature. Only the molecular properties and the wavelength. Okay. So option C, it is going to be the right answer for the molar extension coefficient. Next, question number 38. A water solution of a colored compound has a molar absorptivity. Okay, epsilon value they have given, that is 3200 at 525 nanometer. Calculate the absorbance of 3.4 into 10 to the power of 4 minus 4 solution if a 1 centimeter cell is used. And here what they have given, just the molar absorptivity they have given, that is 3200, and path length mentioned as 1 centimeter and concentration mentioned as 3.4 into 10 to the power of minus 4 moles per liter. So no need to do any corrections here, directly you can calculate by this formula, A equal to epsilon into BC. Okay. So 3200, exactly the units are also equal to the path length 1 centimeter and this 3.4 into 10 to the power of moles per liter, units are also relevant. So if you do this calculation, very simple actually, 3200 into 1 means again 1 only, into 3.4 into 10 to the power of minus 4. So 3.4 into 10 to the power of minus 4. Okay. So if you take this 4 zeros, so 1, 2, 3, 4. So it will become 0.32. 0.32 into 3.4. Right. So in this way also you can delete this negative logarithms in exponential form. So if you multiply this one, you will get the value of 1.09. Very easy answer. Okay. So always simplify the terms so that you will get the answer. Here what is the option they have given? Yeah, D option, 1.09, it is the right answer. Okay, next question, calculate the concentration in microgram per ml of the solution of the albendazole in methanol giving an absorbance of 0.586. That means they have given the absorbance value, okay, at the particular wavelength, and the path length how much they have given, that is 10 mm. 10 mm is nothing but 1 centimeter. Okay, and epsilon value they have given 129, that is molar absorptivity value also they have given. We need to calculate the concentration only. Okay, but concentration wise if you take it, what they have asked in microgram per ml. Generally what we are getting, that is gram per liter, okay, but here what they are asking, microgram per ml. So let us see this epsilon value they have given, B is 1, 10 mm means 1 centimeter, that is also they have given, and absorbance also they have given 0.586. So if you convert this A equal to epsilon into B into C, so we need to calculate the C. How we are going to see? C equal to A by epsilon into B, okay. So what is the absorbance value? That is 0.586. What is the molar absorptivity value? 129 into 1, this is simply 1, okay. So if you convert this, that means how we are going to convert this? So you are not allowed to use the calculators, logarithmic scales, nowhere, okay. So this is how we are going to convert. Almost all, if you take this 129 into 5, okay, so if you multiply this, 645 it will come, okay. If you multiply this by 4, okay, then how much it will come? 129 into 4, almost let us say it is 130, okay. 130 into 4 means 520 it will come, okay. That means the answer lies in between 4 and 5. 5 with multiplication of 5 you are getting 645, and with multiplication of the 4 you are getting 520. So let us see the options here, then you can easily understand, okay. The answer lies in between 4 and 5. So where is the 4 and 5? Here. But what they are asking, in the microgram per ml. So whatever the concentration we got, that is grams per liter. Okay, that grams per liter, it is going to be converted into the grams per liter solution. You need to convert this to microgram per ml. Gram per liter, it is also equal to the mg per ml. So milli, it is going to be converted 4.5, okay. Thereby you are going to see the 10 to the power of minus 3 grams. If it is converted, that is minus 6 micrograms, right. So in case of the milligrams, it is already there. So milligrams to micrograms. Milli means 10 to the power of minus 3, micro means 10 to the power of minus 6. So what you want here, only 4.5 into 10 to the power of minus 3 micrograms, okay. So in this way you are going to convert the milligrams to micrograms. So finally what is the answer here? Let me check. In case of the gram per liter solution, we need to convert this to the microgram per ml, okay. Somewhere around we got 4.54, right, that is gram per liter solution. So this gram per liter solution we need to convert to the microgram per ml. So gram per liter, microgram per ml, gram per ml you need to represent, okay. So micro means 10 to the power of minus 6 grams and divided by ml, 10 to the power of minus 3 liters, right. So in this way they want, but here ml only they are asking, so no need to do this. Actually this is ml means you are going to see the 10 to the power of minus 6 here, right. So this 10 to the power of minus 6 and 10 to the power of minus 6 both get cancelled. So you are going to see the 4.54 microgram per ml. Per liter means then you are going to see the 10 to the power of minus 3 additionally. That's what we have done previously, okay. So in this case, this C option, it is the right answer, okay. 40th question, okay. One more calculation we are observing. Calculate the 𝙂𝙂𝙋, that means epsilon. They are asking molar absorptivity value here. The transition of 2.5 into 10 to the power of minus 4 molar solution of a substance in 1 centimeter path length cell at lambda max, which is having absorbance, okay. absorbance they have given, molar absorptivity they have given, concentration also they have given. What they have given? That is absorbance 1.17, this concentration they have given, and path length they have given. Only what they have asked, that is epsilon value, molar absorptivity value. How we are going to calculate this? A equal to epsilon into BC, the same thing what we have done. So we require epsilon. So epsilon equal to A by BC. Simply if you calculate 1.17 divided by whatever the path length is 1. So no need to bother about this. C is 2.5 into 10 to the power of minus 4. So 1.17 divided by 2.54. If you simplify this factor, you will get the answer. No need to bother about the term aside of it, that is 10 to the power of all these things. Okay. So here they have given 0.468, 0.568, 0.668, 0.768. 1.17 divided by 2.5. If you do this, okay, here they have given the same number here. So no need to bother about this. So if you get whatever it is there, that could be the right answer. Okay. So decimal, if you cancel 11.7 by 25. Okay. So almost all 117 divided by 250 you are getting. Okay. So if you take this as 120, 240 it will come. So almost all it is approximately less than 0.5. Okay. So if it is equal to 125, then 125 by 250 equal to the 0.5. But this value is less than here, means answer is also less than 0.5. So in that way, if you observe here, this is the right answer. Okay. So in this way, you can answer some tricky questions. Next, for a solution of organic ketonic compound, they have given one formula, organic ketonic compound in hexane in a 10 centimeter cell, path length they have given, absorbance was found to be 2.52, absorbance they have given, path length they have given. What is the concentration? C they are asking, and epsilon value also they have given. Okay. Simple, you need to calculate, they have given the moles per liter solution. So let us see how we can calculate the concentration. A by epsilon into path length. So here the path length they have given 10 centimeters. For 1 centimeter means, okay, 1 it will have no m, but 10. So 2.52 it is absorbance divided by 10 into 14. So obviously finally you are going to get the answer 2.52 divided by 140, right? Yeah. So this decimal, if you are going to get it, means you are going to get the 2 to the power of minus 2 here. So 2 and 1, almost all 1.4 and 2.5, it is equal to the 2 14s are 28, right? So in that way you can easily answer the question. The answer is less than 2. So option A, it is the right answer. Okay. Next, according to the diagram, which region has the highest energy? Okay, very fundamental question. Wavelength, it is going to be increased here. So whenever you are going to observe such type of the diagrams, that means the radio waves will have the highest wavelength, whereas gamma waves will have the highest energy. Here radio waves are having the highest wavelength, so energy is less here, and here lowest wavelength, energy is more here. What they have asked, highest energy. So highest energy means options: radio waves, visible rays, gamma rays, infrared. Definitely gamma rays they have given. C is the right answer. Okay. Next, an electron transition from n equal to 1 to n equal to 3. How does this compare to the n equal to 1 to n equal to 2 transitions? Okay, that means the states, okay, transition states, n equal to 1 to n equal to 2 means you can get energy somehow, but whereas n equal to 1 to n equal to 3 means more energy is required. Okay, here also they have asked in terms of the energy. Less energy is required, more energy is required, same energy is required. Energy depends on the temperature. This is completely wrong. Same energy, this is also not relevant. Either A or B. But here if you observe, n equal to 1 to n equal to 3, they have asked. Someone has answered this one. They are keeping the mind n equal to 1 to n equal to 2. But an electron transition from n equal to 1 to n equal to 3, they are asking the question related to here. Okay. So, for this more energy is required. So, when it is compared to n equal to 1 to n equal to 2, the energy is required for this transition. Okay. So, less energy is required for this, not for this. So, in this way some people have given the wrong answer, very bad for that. Next, identify the correct statement. Okay, let us again back to the true and false statements. Absorbance is extensive property of the substance, whereas absorptivity is the intensive property. Yes, definitely. Molar absorptivity value, it is going to be depending on the particulate properties, molecular properties. So, it is an intensive property. Okay, intrinsic character also. So, option A, it is the right answer. Absorbance is intensive property, whereas absorptivity is extensive. No, this is wrong. Both absorbance and absorptivity are intensive. This is also wrong. This is also wrong. These are not extensive. Okay, only the absorbance, after giving the energy only, the absorbance it is going to take place. So, that is the extensive property. Whereas molar absorptivity, it depends on the nature of the molecule, functional groups and chromophores. Okay, so that is the intrinsic property. So, option A, it is the right option here. Okay. Okay, so we are at the question of 45. We are going to complete within 5 questions. Let us see the statement. Select the correct statement from the following option. Spectroscopic methods require less time and more amount of sample. More amount of sample, no, not at all. Less time, okay, this is correct. Spectroscopic methods require more time and more amount of the sample. No, very less amount of the sample you require. So, B is also not correct. Spectroscopic methods require less time and less amount of the sample. Yes, option C, it is the right answer. Let us see option C. Spectroscopic methods require more time and less amount of the sample. Very within the less time we are going to measure it. So, option C, it is going to be the right answer. Okay. So, whatever the techniques, UV, spectroscopy, IR, nephelometry, turbidometry, all these will give within a minutes the results. Next, the relationship between the absorbance and the transmittance. Okay, we know that the formula is A equal to 2 minus log of percentage of transmittance. So, that is why if you observe log percentage of T. So, if it becomes log T is 100 means log 100 percentage of transmittance, whenever 100% of the light is transmitted. Okay. So, log 100 it will become. Log 100 means 2. The value is 2. So, 2 minus 2, 0. No absorbance at all. Okay. So, transmittance, if it is low means absorbance is more. All the light has been absorbed by the particles. So, this is the correct relation between absorbance and the transmittance. Okay. So, we know some of the other formulas also. Generally, we are expressing absorbance A equal to minus logarithm of T to the base 10. Whereas, transmittance we can express incident light, transmitted light divided by incident light. And if you are talking in terms of the percentage, okay, so that is here you can see log of percentage. If as usual transmittance it is there, then you can take the negative logarithm of transmittance becomes the absorbance. If you are taking the percentage of transmittance means here the 2 will come. Okay. So, that is the difference. Next, which of the following is called heat radiation? Okay, that means majorly whenever any object emits the heat, how we can estimate easily? By simple infrared radiation. Okay, so that is the basic fundamental thing. We know that which of the following is called heat radiation. X-rays, gamma rays, microwave, infrared. So, infrared radiation, it is basically detecting the objects based on the heat, okay. And if you are seeing the other rays, majorly microwaves, okay, whenever we are going to use these microwaves ranging from the electromagnetic radiation of 300 megahertz to 300 gigahertz, okay. So, thereby you are going to see the microwaves radiation, and X-rays also have the wavelength, that means whenever the crystalline structure molecules are there, interatomic spaces are there, we are going to determine this. So, X-rays are going to absorb the radiation as well as emission also it is going to take place. In order to investigate any solid structure, whether it is crystalline or not, single crystal, double crystal, okay, a crystal lattice we need to find out, then X-rays are going to be useful. Wherever infrared radiation means these are going to be through the heat, okay. So, the heat, whenever it passing through that, due to the heat radiation we can detect some of our human cells also. Infrared rays are also going to be goggles are also available. So, in that way we can see some of the people in the nights also. Next, arrange the following electromagnetic waves based on order of the energy, okay. So, in terms of the energy, so many questions we have seen today. Here again they are asking electromagnetic waves based on the energy, okay. So, already we have answered one question related to this. Let us see the sequence: X-rays, microwaves, UV rays, gamma rays. Actually, this is a jumbled order, okay. So, order is not proper. Wherever if you are observing the gamma rays here, they have in the order of energy, okay. So, here if you see the wavelength, it is going to be very less. So, energy it is going to be more. So, gamma rays will have more energy than X-rays, than UV, than micro, okay. Whereas microwaves, X-rays, gamma rays, UV, this is also jumbled, this is also jumbled, and UV, X-rays, gamma, this is also jumbled, okay. After the UV, you are observing the visible radiation, then IR radiation, then microwave radiation, okay. Afterwards, we are observing the gamma rays, and that means in terms of the wavelength if you are seeing, lastly we are observing the radio waves, not the gamma rays, okay. Gamma rays very first we are going to see, already we have seen in the previous slides also, okay. So, previous one also we have seen, depending on the energy of the rays, just I think 40, which question we have seen that okay. So, yeah, this one, electromagnetic spectrum, radio waves, microwaves, IR, visible, UV, X-rays and gamma rays, right. So, you are going to observe the sequence of the wavelength. So, wavelength it is high for the radio waves, whereas less for the gamma rays, whereas energy is high for the gamma rays, okay. So, then X-rays, then UV, then visible, then IR, then microwave. So, in that question what they have given? Gamma rays given, X-rays given, UV given, micro given, okay. So, they have skipped these two, okay, fine. But order you need to take, the energy is very high for the gamma rays, okay. So, we are at the question of 48, okay. Let us move it fast. Okay. Next, 49. Number of waves per centimeter. Very easy question. Per centimeter, if you are going to calculate how many number of waves, that is called as wave number. Very easy question. Wavelength, wave number, frequency, magnetic field. Definitely wave number is the right answer. So, no need to discuss it again. Next, last question. UV visible spectroscopy measures the transitions between. Very fundamental question. UV visible spectrophotometer, it is going to be used for the electromagnetic radiation, that means the molecular level, which is going to take the absorption spectroscopy, and it is majorly the electronic transitions are involved. gamma electrons, sigma electrons, pi electrons, n electrons. Okay. So let us see the options: vibrational energy levels, rotational energy levels, electronic energy levels, and nuclear energy levels. Definitely option C, it is going to be the right answer. And we also called as these are observed in the IR. Rotational means microwave, okay, and nuclear energy levels means majorly in the NMR we are going to observe. So these are the clear explanation of the topic analysis weekly test MCQs. Today you have written the exam for this, okay. So I think everyone got the answers for all the questions. Hope you have done well. So let us see the answers. Who has scored highest marks in this subject, okay. So again we will meet. Thank you students, thank you for attending.